So the file that you should be looking for right now, it's in the Session 5 folder. It is called Massing Project. Now, Massing Project. So go into the Session 6 folder rather than Session 5. Session 6, Massing Project. That's the file you want to look at here. And you're just going to see some dual curved walls. Massing Project in Session 6. So nothing too extravagant here, but what we've got is a wall that's been placed using the wall by face tool, and it's curved both in plan and in section, so you folks can see what's happening there. Massing Project. Now what I want you folks to do is to grab the window tool and put a window into the face of this thing, and you'll notice as you pass your cursor over this that the window stays vertical no matter where you place it. So that obviously is no good, and your everyday windows, this is the way they're going to work. Everyday windows always insert themselves vertically. So if you folks place a wall in a project using the wall by face command, so if you place a Revit wall on the face of a massing object and then you go to put a window in it, the window would stay vertical. So what we need to do is construct a window that will follow the normal, right? So we mean the tangent to the surface, so that the normal is perpendicular to the surface, and we're gonna have a window that does that, and we're gonna build that right now. So the special family that facilitates this process, so if you go to File, New Family, Generic Model, Face Based. So go to File, New Family, Generic Model, Face Based. So just so you have a sense of how this is all oriented, we are looking downwards in this view. This is not a wall elevation. You're presented with, Revit just calls it an extrusion, so you're looking downwards. So we're building this window as if it's lying on the floor. In the window template, we build the window as if it's standing up. Now, you'll notice, unlike the window door template, there is no possibility to build an opening in it. So you end up having to use a void and cut a hole through your little piece of solid here. And again, the solid doesn't get, this one here, this square solid, doesn't get loaded into the project. It's just here to help you build your geometry. Just like the wall in a window template doesn't get inserted into a project either. So this time we're going to build a circular window, so we're going to build a circular hole. So what we're going to do is we're going to put in one reference plane and what dimension? I think 2'10". Doesn't really matter. In the notes it's in metric. We'll do this one in imperial because we're Canadian and we have those skills. Yes? Not yet. I will. I'm putting in a reference plane right now. This reference plane is going to be the one that controls the size of the window. You can see I've drawn it on the screen. It's 2'10", and it's a horizontal reference plane, 2'10", away from the central reference plane. So that's step one. So this is a generic model right now. So again, we've used the generic model face-based template. So this is page 4 in our notes. We want this to be a window. So what we need to do is go up to the family category button, which is the yellow folder in the top left corner. and switch this from being generic model, scroll down in the list until you find Windows, and put it into the window category. So now when this is loaded into your project, Revit would consider it a window. It would put it in your window schedule, and this family will be stored in the window folder in your project. So we've got our reference plane drawn here, so this is step 3 now. And so what we need to do is run a dimension between these two reference planes so that we can make this parametric. So after you've placed the dimension, hit escape twice, go back and select the dimension. And of course this is going to control the distance from the center of the circle to the radius. So this is the radius of the window. So here, once the dimension is selected, this is the opening radius for the window. And go ahead and hit OK. Now this reference plane is going to be is here so that in the future we can build the hinge for the window, because it's going to have an operable, sort of like a shutter that goes over the top of it, so that's why this is there. What we're going to do now is go to the Create tab, and from the Void Forms drop-down, choose Void Extrusion. So we're going to carve the hole through our host. Once the Void Extrusion command has started, grab the Circle tool, start at the intersection of the two reference planes in the middle, and draw a circle that goes up and touches that reference plane which we created moments ago. Now, because we drew that circle up and touching that reference plane does not mean that if you were to change the value of the parameter here, this length parameter, that the circle would change its size. That wouldn't happen. So what we do need to do is throw on a radial dimension. So go and grab the radial dimension command and dimension the radius of our circle here and place it in the view. Now we've already created that opening radius dimension, so there's no need for us to have to do it again. So hit escape twice and select the dimension that we've just created for this void and select it. Now you'll see at the menu on the top of the screen here that we have our opening radius and parameter. It's already there. You can just select it. And now that same parameter is being used on both. Have a quick look over onto the properties panel here and ensure that in the solid void row it does say void. If it doesn't, you can switch it now so that it does say void. Because what we want to do is to cut a hole now through our solid. Now you can see that there are other dimensions in here. What these are meant to do, and this is in the middle of page 4 on the left screenshot, those two dimensions are designed to ensure that the void here stays constrained over the two reference planes. Now we don't actually have to do this. In the ensuing years, it's probably been about 5 years since we've been watching how this exercise performs in different versions of Revit. Those dimensions were there to make sure that this circle didn't start like moving around. So I've played with it for a couple of years, and we don't need to bother with those two other dimensions. You can do them later. It's no big deal, but you can finish now. And we're going to go look at this thing in 3D to see the void. So View, and then Default 3D. So View tab, Default 3D. There is the void. So it's orange, and it's not cutting anything. So if we go over to page 5, top of the page there, you can see what we've got to do with this void. We've got to select it, and we've got to grab the triangular drag handles at the top and bottom and drag them up and down. Now the purpose of this is you need a void that's tall enough so that if you're ever putting this window in a really thick wall, like one that's like 2 feet thick, that this void will cut entirely through that wall. Because what this extrusion, that rectangular little slab thing represents is it could be a roof, it could be a floor, it could be a wall. And this void that we're building will cut whatever face of whatever that you put it in your project. So this window, you could put it on the face of a wall, you can put it on the face of a floor, a roof, a ceiling, anything. It's a great thing about these families. But you want to make sure that the void is thick enough that it'll carve through whatever. So this thing is what, 7 feet deep, 4 foot in one direction, 3 in the other? That's plenty. So now what we need to do is use the cut geometry tool and tell Revit that we want the hole to be cut through the host. So now in our projects, that same opening will be cut through whatever this window is going to be inserted into. Now, similarly to how we build windows with the window template, we need to add reference planes that will control where our frame for the window sits within the depth of the wall, roof, or floor that we insert this into. So in step 6, page 5, it says in the right or left elevation view. So I will grab the left elevation view here. So what we need to do is add some reference planes here that will control where our window frame sits. Now we're going to have the window frame sit a little bit above the surface of our floor or wall here. If we wanted to, we could have it recessed. So what I'm talking about is it's just a design thing. In this particular case, I want the window frame to project a little bit outside the wall face. It's just the look that I'm after. Of course, with most windows, we would have our exterior reference plane for the frame recessed into the wall. So here we're making a decision about which direction we're going with that, and we're going to have that reference plane sit outside the wall like you see here. So that is the outside face of the window frame. We need one for the inside face of the window frame, so I'm drawing that within the thickness of our host there. And we need one more reference plane that's going to be for the glass. Now, I realize this isn't the notes, but it's definitely worth talking about again, so you folks are aware of this. When you select one of these reference planes here, you will see up in the properties palette that there's a checkbox at the top there called wall closure. It's this one right here. And what I want to do here is discuss what this does. So every door and window should have two reference planes that have wall closure built into them. So here's our wall. And here's the reference planes for the inside and outside face of the window frame. So you add these yourself. And what you want to do is for each, for the window frame on the inside and outside, is you want to ensure that you enable the wall closure setting. So what this does is once you've modeled in your frame, whether it's a door or a window, what Revit will do in the context of your project, if those boxes are enabled, it will return finishes back to those planes on each side. If these two reference planes have that wall closure feature checked off. So 2 planes, not 3, not 1, 2. And you want them to be at the inside and outside edge of your door or window frame. So we're going to check them in this case. Okay, so the inner one here, for our inside face of frame, we're going to check it. And now, what about on the outside? Well, in this case, our finishes aren't going to wrap outwards, so it doesn't really matter for this particular window, but I'll just check it anyway. So for most windows that are set within the depth of a wall and recessed on the inside and outside, you'd want that closure feature checked. Okay, so now what we need to do is set up some dimensions here, and I'm going to change the scale of the view so it's a little easier to see my dimensions. So I'm changing my scale from 1/2 inch to a foot to 1.5 inches to a foot. It'll just kind of scale down my text size so it's a little easier to see. So here's the 3 dimensions that we need. We need 1 dimension for the overall depth of the window frame from the uppermost reference plane to the bottom. So that's 1 reference plane we need. We need another reference plane from the top reference plane, which is the face of our frame, back down to the face of the host. So this will allow us to control how far proud of the outside face of the wall our window frame is. That's dimension number 2. Finally, we need a 3rd dimension that sets back the glass, allows us to control the recess value for the glass from our outside edge of the window frame. So those are the 3 dimensions that are required. Now this scale is a little bit small here for you folks to see it, so I'll crank the scale up again here so it makes these dimensions easier for you folks to see. So we've got 3 dimensions. This one here is controlling how far the frame sits in front of the outside face of the wall. This one sits, controls how far the glass will sit recessed from the face of our window frame. And we need to name 2 of these reference planes. The top one is going to be named, I'm just going to name it here. You can name it in the properties palette or you can name it right here, it doesn't matter. So this is my face of window frame. And then the next one down is your face of glass. So the one below it, that's my face of glass. Okay, so what we need to do is give these dimensions some labels so that people in the project will know what they're about, what these dimensions are designed to do. So the one here that goes from the face of my wall up to the face of my frame, I'm going to go up to the new label button and I'm going to create a parameter that's called frame projection from wall. Now I think in the notes it calls it frame offset from face. You can call it whatever you want. Regardless of what you choose to name a parameter, you really want to tell your users, using the name of the parameter, what it does. So either one of those works. So now we've got our next dimension here, which sets how far the glass sits back from the face of the frame. So we will rename it here. So this is our glass setback from the frame. And then the last one is our frame depth. Now these dimensions are pretty ugly. So I'm going to make my frame projection, I'm going to make it 2 inches. I'm going to make my glass setback. So here you can click once on the dimension, click twice on the dimension, and now you can change its value. So I'll make it 1 inch for my glass setback, and I'll make my frame depth, I'll make it 8 inches. Looks like in the notes, the frame depth actually is 250, so that's 10 inches, so I will do that here. There we go. Oh, what I see, they've got the frame offset from face is 4 inches, so I will do that here too. So I'll leave these values up here on the screen here for a moment. So your checklist of things to do right now is to make sure that your outside reference plane for the frame is named, and that it's named for the glass as well, and that you put on dimensions here with values on them. So now what we need to do is go back to the ref level view, the plan view for this family. Double click on it. So we're back looking at the opening for our family. Now before we proceed any further, I just want to make sure that you folks have gone to family, category, and parameters, and that you have chosen windows as the category. So make sure that that's happened. So we're going to build the frame around the outside of the window frame. So we're going to go to Create, and we're going to go to Extrusion. Now, we need to tell Revit what plane this extrusion is sitting on. So we're going to use the Set Work Plane tool, which you'll see up on the screen here. And I could have done it before I started the extrusion command, or I can do it now. It doesn't matter. And I'm going to choose my window frame reference planes, so the one I named. And this is why we named them, so that when we use the Set Work Plane command, we can see it in this list. There we go. Now, we can't use the pick tool on the void edge. See here? It just doesn't find it. If you folks were building a window, and I was doing a rectangular window, and I was using the window template, we could just use pick, turn on lock, and it would grab the edge. No such luck here. Revit will not pick the edge of a void, unfortunately, and this is what the void is creating, this edge. So we'll just draw the circle ourselves. So start from the center, come on out, get to the same location up to the reference plane, so you should be 2'10" to begin with. So that's our outer frame edge. Let's use the offset command, and we're going to offset it 4 inches, I guess. It's a real thick frame. 4 inches. And offset the circle towards the interior. So we've got our two circles for the inside and outside edge of the frame. Throw on a couple of radial dimensions. One to the inside circle, one to the outside circle. Now, as you folks might expect, for that 2'10" dimension, we can associate it. So if you click on the 2'10" dimension after you've escaped out of the dimension command, once you've selected that 2'10" dimension, you'll see the opening radius parameter up here, and you can associate it with it. For the 2'6" value here, we need to make a new parameter for it, and this is going to be called frame inner radius. Frame inner radius. Now, you can see how I spelled that parameter wrong. If you happen to misspell a parameter name while you're working, we'll talk about the next dialog box, your family types. This is where you can sort this out. So if you have misspelled one of these things, there it is there. Just put your cursor in that row and hit the pencil icon at the bottom, and go back and change the spelling. Fix it up and hit OK. Now, what if we want to be able to control the frame width? Like, what if I want to say frame width equals 4 inches? Can I run an aligned dimension from, like, from here on this thing to here? No, you can't dimension between these two curves directly. So you can control the width between the two of them. Doesn't work. So this isn't in the notes, but I'm going to show you how we can work with family types and work with formulas to make this work. So what we're going to introduce here is a frame width parameter, and we're going to ask Revit to do the math for us to set this up. So inside the family types dialog box, that is the one with the 4 blue squares on it, on the top left, down at the bottom you'll see the little asterisk icon here, second from the left, that will allow us to make a new parameter, and we're going to call it frame width. Frame width. And we're going to give it a value of 4 inches initially here, 4 inches for the frame width. So right now we know that if we take our opening radius and we subtract our frame width, that would give us our frame inner radius, right? So the difference between our opening radius and our frame inner radius, of course, is the frame width. So what's going to happen is that our frame inner radius is going to be driven, instead of being driven by a number, it's going to be driven by a formula. So case sensitive, this is what we write. Opening radius, again it's case sensitive with the original title that you use down here, subtract frame width, and again case sensitive, spelling sensitive, make sure you've got the right casing for both. And when you're done, you'll see that frame inner radius turned gray, as did the value. This means that you can no longer directly control the value of this parameter. Now, a good question to ask yourself at this time is, do your users really need to see this parameter anymore? No. Can you hide it? No. Okay, can we bury it? Yes. So put your cursor in the frame inner radius here, and go back down to the pencil icon so that we can edit this parameter. So no, we can't hide it, but we can change where it's grouped. Now you folks can see that there's these blue headings here. These are groups. So I can move it from the dimensions group to something like the other group. And so what this will do is it will move this parameter from this zone here to one that's farther down in family type. So I'm going to choose other and hit OK, and now it's buried down at the bottom of the list, right? People will, they're not going to look for it, they don't care, it's grayed out. You're just getting it out of the way so that the parameters that matter are shown at the top. So that's great. We're done. Yes, opening radius, subtract the frame width, and that is for your frame inner radius parameter. Go over to the formula section, and I know it's small on the screen up here, but yeah, it's opening radius minus the frame width in the formula row, or in the formula column. So you're altering the value of frame inner radius. And I have to show my screen at this resolution, which is higher than the projector can handle, so that you folks get an HD video on YouTube. So that's why I'm recording this at this resolution. So unfortunately, not so good for the projector, and not so good for all you people who insist on sitting at the back. What is the deal? Like, I got glasses, you got glasses, you can't see, you're sitting at the back. What the heck? Next week I want to see you all like sitting on top of each other here in the front row, right? So there you go. So that's done. Now, a couple more things to deal with here. The extrusion for our window, you can see it's a positive value. That means it's going to extrude towards you. So this extrusion is coming out of the page towards you, which means it's going upwards, which of course doesn't make sense. Now, we could give it a negative value so it goes back into the wall, but we're not going to bother because we're going to constrain the back face of this solid to that reference plane we made a few moments ago. Now, a couple more things. Right by the material row, you can see that there's a little gray box on the side, and what we want to do is add a material parameter like we've done in previous weeks. So hit that little gray button, pop up the dialog here, and add a material parameter. So we'll call this the frame material so that people know what this thing does. It changes the material so you can make it stainless or aluminum or what have you in the project. So hit OK and OK. Equal sign there. Great. Subcategory. This thing is part of the frame. So that will allow us to put this thing in the right category, subcategory rather. Hit finish. And so go back to your left elevation view, and sure enough, you folks can see that the this thing is being extruded. Awkward moment. I realize I didn't associate it with the right reference plane. Okay. So I think pick new. Can I? No. The instructor is kind of euchred. Placement. Oh no, maybe no. Oh yeah, no, I don't want to do that. Holy mackerel. Okay, so I'm just going to bust it off the face of my work plane here. See that now? So now neither the top edge or the bottom edge of my particular extrusion is associated with anything, but just by dragging it down, you folks can see what's going to happen here. See, Revit is super forgiving. So now I can lock that face, grab the top here so I can change the depth of this extrusion and just pull it down until it touches that work plane at the bottom and lock it as well. So now my extrusion, when I look at it in 3D, is going to those two reference planes. This is looking a little chunky. I can change the scale here so that it's, there we go, a little nicer. Turn on shading, SD, and there's our frame. Now, the next thing we need to do is the glass. This is step 8 on page 5. So we go back to the plan view again. And we're going to create and extrusion. So this time it says use set to set your work plane to face of glass. So once you've started the extrusion command, hit the set work plane tool, choose face of glass out of your list, and hit OK. Then it says set the subcategory to glass. So here in the properties palette, grab your subcategory, make it glass, and set the extrusion end value to -1 inch. This means that the glass is going to go downwards into our window frame, which is cool. And once that's done, we can just use the pick tool with lock enabled and just pick the 2 halves of our circular window, and that's it, we're done. So in 3D, when we look at it with shading, you can see the glass is there, the frame is there, and now we can move on to, what is this, page 6. So what we're going to do here is we're going to start talking about how we can use reference lines to make hinged geometry. Now, if you guys want to make a hinged, let's say you want to make a hinged casement window. So the way we're kind of building this shutter is it's going to be like an awning window that the hinge is at the top and the shutter will swing open outwards. If you folks were going to try and build a window that had like one opening vent, so remember that 313 window that we saw earlier in the evening. So I'll just draw something simplistic here. So here's a window, and what I want to do is to make is put in 2 reference lines. And that reference line would be put right along the inside of the bottom of the window, right at the frame here. And then there'd be another reference line on which the frame would live. So looking in plan, so I'm just not drawing the glass right now. I'll leave this up on the board if you folks want to grab a picture of it later. So I draw a reference line that's right here along the inside edge of the frame. And I'm going to draw it adjacent to it so you folks can see the green line. And then there'd be another reference line that my vent would live on. Let me just grab the blue here so I can draw in the glass. So these 2 extrusions, the one for the vent frame and the one for the glass. These 2 here would be hosted on this reference line. Why do you need 2 reference lines? Well, for a reference line to truly be able to hinge, it needs to connect to another reference line. So what I'm saying is that if you try to do this, let's say that you had a reference plane here, so that's for the front of my window frame, and another reference plane here for the outside edge of my window frame, and and you do need to add a reference plane for the inside edge of your window frame. So this is inside edge, and this is my outside edge here. Just draw a little circular on this. So if I just try to put one reference line from the intersection of my inside frame edge and the reference plane of the outside face of my frame, it wouldn't hinge. It would break. I don't know why. So what I've learned is that, yes, I do need this reference plane here for my inside frame edge, but more importantly, I need that reference line. So you need 2 reference to create a hinge. Can't just do it with 1. So I need 2 of them. So that's why in our example here, we're building geometry. So in plan, these 2 reference lines are there, and what we'll be able to do is have a dimension or an angle parameter that will allow us to control the opening angle. Now you only need to do this if, for rendering purposes, you want to be able to show an open window in your renderings. Like 99% of the time, nobody cares, your developer doesn't care. But if you're interested in doing sort of like a rendering that gives your building a little bit of a lived-in look, you know, you would model it with the window open. And I would model my house with 12 towels on my bathroom floor. Because my kids can't seem to find a damn laundry basket. I've even taken to posting pictures of the bathroom and putting it on social media. Come home, you've left the towels on the floor. You sad excuse of a soul. All right, so we've got to put in those 2 reference planes here, so let's do that. Right elevation view, it says in the notes, right elevation view. So here you can see the, it's going to be hinging from the right-hand side. And there's a reference plane that we created in our first step. So this is going to define the hinge location here in this vicinity of our family. So first of all, on the Create tab, there is our reference line command, not reference plane, reference line. And I'm purposely going to draw it sort of a distance away from this reference plane initially. So there's our 2 reference lines. Now by drawing them in one go, This reference line knows that it is to stay hinged around this reference line here. So this reference line here functions as the hinge, and then the second longer angled reference line functions as the hosting work plane for our shutter. So now we're going to use the align command to line everything up. So grab the align command, pick the reference plane at the edge of the window, and pull the reference line, the vertical one, over so that's locked and aligned to the reference plane. So what we want to be able to do now is to control where this hinge sits above the window. So this would allow us, if we wanted to create a small gap between the hinge and the frame, just if we needed some clearance for hardware. So grab the dimension command and dimension from the level up to where those two reference lines intersect. You'll get a blue dot. So this is a point constraint. So what we're doing here is we are controlling the location of that intersection point between those two reference lines. So we're going to make this dimension parametric, obviously. And if the value of this dimension changes, it's going to move that intersection around. So this dimension here is going to be our flap hinge length. So up to the label menu, this is flap hinge length. Oh, you know what? I'm just looking in the notes here. I put it in the wrong place. My bad. It's here from this top reference plane at the top of the window. And here's a common mistake that people have made, and I'll just put this in here so it's for reference. Do not, when you start this dimension, put it on the geometry. That is not a reference. That's not a strong enough reference for a parametric dimension to be starting from. You need to start from a reference plane whenever possible. So click there first, and then go up and pick that intersection and place it. So yeah, this is going to be our flap hinge length. So my value there is a bit much. I think we used a value of 3 inches in the notes, but it can be anything, you know, greater than 0. It doesn't really matter. I'll make it 0.5 inch. Now, what we need to be able to do next is control the angle of this reference line so that we can, whenever we want, take that shutter that's covering over our window and open it up so we can let the light in. So we're going to use an angular dimension. So from the dimension menu, grab the angular dimension. And again, your first click should be on the reference plane at the top of the window. Then your second click can be on the reference line and place that dimension somewhere. Now this is going to be our flap angle, and it's going to be an instance parameter. So after you've put in the angular dimension, select it and make a parameter for it. And it's going to be a type, or it's going to be an instance parameter rather, so that each placement of this window can have its own value of the flap angle. So that way the shutter on each window can be a different angle. Some of them could be 0, so it's closed. Some of them it could be 180 degrees, so it's fully open. Some of them you can make it so it's partially open. So going back to the example on the board here, when you guys are making your opening angle here for this reference line to open up your window vent, make it an instance parameter so that each window can look like it's, you know, got its own degree of openness. And that'll just make it look a little bit more random and a little bit more realistic. So here in our notes then we're making in Revit we're making the dimension an instance parameter. If you forget You can always come back to it later, click on the dimension, and there's an instance parameter checkbox. So once the dimension is selected, up on the ribbon, instance parameter is available. And of course, in family types, it's available here too. You would just go and find the parameter in question, put your cursor in that row, and then hit the pencil icon at the bottom, and here you can switch it between type and instance in this case as well. So now everything's ready. Now we just need to build our geometry so it's living on this reference line. So as the reference line changes its location, changes its angle, so will all the geometry that's built on it. So let's go into 3D here. And if we spin the model around, you guys can see the reference line going up on an angle. And if you put your cursor on it, we saw these reference lines in the massing class. And each reference line actually has 4 work planes on it. There are 2 planes that run along the length of the reference line, a horizontal one and a vertical one, so you've got that kind of cruciform arrangement. And then there are work planes at the ends of the reference line, and you can see them here, the smaller squares at the end. So we are going to be building our cover over the window on the horizontal longitudinal plane that's defined in this reference line. So if you go to the Create tab, grab the Set Work Plane command, and in this case choose Pick a Plane. And then hit OK. Put your cursor out into the drawing area, and Revit's going to show you the different work planes that you could choose to build our geometry on. We don't want it on the end one. Now this work plane here, this is the vertical work plane of this reference line. We don't want this one, we want the horizontal one, so we have to hit the tab key once so we pick that horizontal plane, and we're there. So to confirm, you can hit Show, which is beside Set, and you can see just by orbiting around that yes, we have successfully picked that work plane, and now we can start modeling. All right, so what we're going to do now is build an extrusion, and we'll make its end value 1 inch. So this will be a 1 inch thick cap on the window. I'm going to give it the subcategory of, I guess, frame and mullion as well. And if we want to give it a material parameter so it will render like something, we can hit the little gray box on the right hand side of the material parameter. If we want it to make it so it renders the same material as the frame, you just hit that and hit OK. If you wanted to give it a new and unique material parameter so it would be a different material for the shutter than from the frame, you would add a material parameter for it at the bottom here. So this would be the shutter material. Or the flap, whatever you want to call it. You can come back and name it later. So now these two solids have their own material parameter so that they will, you can give them different appearances in the context of your project. This is where it gets a little tricky. So we're going to draw the circle for this thing, and I'm not going to draw it down towards the hinge. I'm going to draw it down sort of closer. And again, you need to be right on the reference line. Make sure that that is your first click. And then draw your circle outwards. Now, once you have created the circle, you can hit Escape to get out of the circle command. Interesting fact, I'm sure some of you knew this already, but if you click on a geometry and you see dimensions, sometimes you will see that there is a a little kind of dimension icon underneath it. Now Revit's not displaying it in this case, but it would allow you to turn a temporary dimension into a real permanent dimension. Just something you folks might have seen. We're going to have to actually put in a radial dimension here and just click on the circle to place that radial dimension. This of course is opening radius. So once you've placed that dimension, just go back, select it, and from the label drop down at the top of the screen, associate it with the opening radius parameter. So that's that. So now it's always going to match the opening radius of our window. No, you got to use the radial dimension command. And then once you're done, you have to hit escape twice so that you're back in modify mode. And then you can select the dimension afterwards, and you'll see opening radius in the menu, and you can associate it with that parameter. So, okay, let's do this again. I'll delete it. So I'm going into the dimension commands and grabbing the radial dimension tool, picking my pink circle, and placing it. Hit escape twice. You'll no longer be in the dimension command. Now select the dimension, and you'll see the label menu. Drop down and choose opening radius. So this means now that our circle will stay the right size. Now what we need to do is ensure that the edge of our shutter stays right down here at the hinge point. So what we need to do is run a dimension from our hinge point here up to the circle. Now rather than, I'll show you one way that I guess might work. Here I'm just kind of zoomed in a bit on where those two reference lines intersect. And I'm just going to use an aligned dimension here for doing a linear dimension. So you folks can see I've created the circle. Now I'm just zooming in on the hinge here. And I'll turn off show work plane so that that blue stuff's out of the way. So here we go. Aligned dimension. I start from the knuckle point here, and you can see that once you see that blue dot, and you can see it's also highlighting the green line. You want to see the blue dot hover, and also the upper green line to turn blue. If it picks this one or turns the lower one blue, just hit the tab key until you see, so just as you're hovering over this intersection, hover until you see the blue dot and the angled reference line turn a darker shade of green. Now you can click, place the first endpoint of the dimension, and then I could go up and just choose this quadrant here in the circle. Now you don't get any feedback, unfortunately. But wait a second, I wanted Revit to choose this quadrant. It might not let you do that. So again, let's just try it again. Nope. Okay, so now what? How can I keep the circle so that this piece here will be right at the hinge? Well, hold on a second, we're right at the center of the circle. So again, opening radius. That will take our circle, slide it down the line, so at the edge of it is right at the hinge. So this is perfect. That's all we need to do. So again, let me go through that step. Grab the dimension command, the align dimension, zoom in 3D, and kind of orbit around until you can see where those two reference lines intersect. Look for the blue dot. That's click number one. And then just put your cursor anywhere along the edge of the circle, and Revit will snap to the center of the circle and place the dimension. So hit escape twice, pick the dimension now, and choose again your opening radius value out of the menu. That's it, you're done, hit finish. So there's your shutter. So now we want to test and make sure everything's working, right? We want to make sure that all of our parameters are doing their job. So let's go up into family types. And I'm going to change the opening radius to something smaller, like maybe 2'6". And just make sure that everything changes size. That's looking good. Back into family types, let's change the flap angle to something like 15 degrees. So you can see our flap is closing. So just make sure that everything's adjusting nicely when you're in the family types dialog box and changing values. So we're going to move on to the next section here. But what I'm going to do before we get to that next section is I'm just going to show you here what this family can do. So in the notes here it says save your family as portal window with flaps. So I'm just going to save it here. Throw it on the desktop. Portal window with flap. Now, what I've done here is I've closed down all my tabs so that I've just got the 3D window of my new family that I've created, and also that massing project I was showing you folks earlier. So what I'm going to do here is load my new portal window. I'm going to load it into my massing project, and I'll show you folks. Look what it does. See how it follows the curvature of my wall? So I'm going to place a few of these things in here. And because we made that flap angle an instance parameter, it means that each one of these windows can have its own value of the flap angle so that we can make these things look like they're in various angles and being used. So after you've had a chance to put a few of these windows in that massing project, save your window into the share-in folder. I'm going to just stop the recording now because we're moving on to a new section, and then I'll restart.